All right. You can skip most of the part. This is just for your information. Very, very advanced thing is covered in the material. That is not needed. But you should understand the term, the word, and the reason. That's the purpose of this. So there is no need for going through all the slides. But I already gave you this material. You have the reference anyway. Okay. Once you know the totally internal how Hadoop is written, if you are interested in those kind of things, then it might help you at that particular time. Okay. But for the normal work and whatever we are going to do, and for the course and for the applications that you are going to do, this doesn't matter at all. Okay. So what we have learned? We have learned that in Hadoop, we have got job tracker, task tracker, name node, data node, secondary name node. This port 50070, this we have learned this. Name node, data node, responsible for distribution of data. Job tracker, task tracker, responsible for computation, MapReduce. Correct? Task trackers will work on the corresponding data node, data locality. Job tracker will track whether the jobs are running or not. If any job is failed, it will contact the name node, ask where is the duplicate copy, will go there and start the process. One question. Assume that Ravi is doing that particular task and the node of Ravi is dying because of lack of resources. Seiko is having the copy of this data, let's say. So what the job tracker will do? Job tracker is going to run what exactly Ravi was supposed to do in Seiko. Assume that now Ravi came up. Possible, right? What will happen? Now Seiko is running what Ravi was supposed to do, and unfortunately Ravi also came up. You will get a wrong result, correct? Because one more person is adding an extra. But MapReduce is very intelligent, and that is what the job tracker is doing. Job tracker knows that it is a duplicate copy of the job. Whichever is first completed, it will take that, and the other one it will kill, so that you will not get any wrong result. See how many things are happening internally. What is that process called? Ability of the MapReduce architecture to run a job in the duplicate machine. I told you this is a very important question. It's speculative execution. Right? Yesterday we have covered that, speculative execution. And always remember, this is also another question asked. Okay? Let's assume that I have got two blocks of 128 MB data, our twinkle twinkle little star and little star hello, right? And assume that we have got two 128 MB blocks. Seiko, are you?
Yes.
So there are two blocks of data. How many mappers? How many reducers? Very good question. Tell me what's the answer. How many mappers will be there? There are two blocks of data.
Two mappers.
Okay. How many reducers will be there?
Two. One reducer. Multiple reducers.
We can't say that's the answer.
As
As you told, one or two reducers. But mappers, how many? No,
Two
not one.
mappers.
How many blocks are there?
Two.
2. Answer is wrong. Answer is can be more than 2 mappers. Why? Speculative execution, one node can die, no? Remember that, okay? So, to not divide that blocks and then tell that, okay, it will be exactly this many mappers.
When it dies, then only that will come up, right? Until then it runs only 2, right?
No, it is running 3. And then the job tracker will kill only when the first result came in, correct? Just now I told you, right? So, it is more than 2, all right? Number of reducers, you cannot decide. So, can you tell me what are things this job tracker is doing? Job tracker is dividing the MapReduce logic to each individual node, correct? Job tracker is monitoring whether the MapReduce job is running successfully or not, right? Job tracker is making sure that the results are being collected and that pipe is used and then the data is sent after sorting to the reducers and then the result is produced, correct? Job tracker is responsible if speculative execution is there, then kill one of them and then accept the other, correct? This is the big story of Hadoop version 1.
Yeah, I have a question. So when we use, right, this Hadoop and DFS, when we distribute the file first time, so it distributes that name node to different data nodes, saying that, okay, this I sent to this guy. How long that would be present, that information? Because assume today I'm running one program against to that file, maybe after the day or later after, the simultaneously if some other resource can execute on the same file.
Absolutely possible. What is the problem? It is reading only, no?
Reading only, but how long that will keep in the name node saying that, okay, this file is distributed, this blocks to this guy.
Name node will keep all the information in the RAM. I have written it here.
Right.
It will be written to the disk also, and the copy of that day is there in the secondary name node also.
So, okay.
When you are reading, what I am telling is that even though it is written, let us say 8:00 AM, I put some data and it is available on the node Ravi and Psycho. That data is already available in the RAM of name node, and at regular intervals, I think it is 10 seconds or something, it will be writing that data to the disk as well. Now at 8:10, if you are putting again another file, it will be available in the RAM, but it will not be written to the disk until the next 10 seconds are happening. So, at every regular intervals, the data is written to the disk as well as it is kept in the RAM. It is kept in the RAM because whenever some request is coming, it is immediately being given. It will not wait for reading from the disk. But assume that you shut down your Hadoop cluster and restarted the Hadoop cluster. From where it is going to read that particular old data, it is written onto the disk, and from there it will read it. Now, if you ask me, between that 8:10 and 8:00, if you shut down, yes, you will lose little information. That normally does not happen, but it is possible. And also, name node is a daemon node. If name node is gone, your Hadoop cluster cannot work. And what that means will do? Shut down, go to the secondary name node, take that file and put it in the name node, restart it. That is the reason why secondary name node is there. And in Hadoop 1, unfortunately, secondary name node is active passive. What does that mean? If name node is dying, automatically secondary name node will not come. It is a manual task. Now, one more question, okay? Since you asked this, these are all admin tasks. Assume that today you put a terabyte of data and it is distributed into, let us say, 30 nodes. In the weekend, the people added 100 more nodes because new business and new applications are coming. And now I am going to put another 10 gigabytes of data. That 10 gigabytes will be now distributed in the old plus new. Now you got a data skew. What is meant by data skew? More data here and less data here. And your processing speeds will now vary, creating a problem. Because here, your MapReduce is going to take more time because more data is there. Here, there is only less data, so it is going to take less time. So, there is a command admin will do called DFS admin, disk balance. And when you do that, it will take that entire data, reshuffle it, and then make it equivalent. In the weekends, if you ask in our companies and all, 2 days is completely going for disk balancing the jobs. All right. Now, I told you about this name node, data node, and job tracker and task. This is job tracker. And I told you in Hadoop 1 secondary name node is active, passive. This is Hadoop 1. It is sad that Hadoop 1 failed. 2008 or 2010, the technology came in. By 2011 and 2012, when a 4,000 node cluster was used for jobs, Hadoop 1 failed. Can you guess the reason? It's obvious. It is obvious and very clear that it will fail. The failure was because of this guy. Why? Job tracker, I told you now, 100 and more responsibilities for job tracker, and when the jobs are more and when lots and lots of jobs are coming, job tracker was not able to track of all these things that I told you. It became a big bottleneck, unlike the name node. They designed name node very well. When you ask the data, name node will tell, okay, go there and fetch the data, so that name node is not a bottleneck. But job tracker, no. Job tracker has to schedule speculative execution, making sure the tasks are running, distribute the tasks. Everything was done by job tracker. They told it is not possible. So what your manager will do, if suppose there is only one person in the team who is responsible for everything, he will not increase the salary of that person thinking that he is working more. Instead, he will hire another 5 more people, correct? They destroyed and removed that job tracker completely from the architecture. So from today onwards, never say there is job tracker. I told you all these things just for giving you the concepts. They took that job tracker and they told that, first of all, there is a big problem this job tracker was doing. Okay, Ravi is having a 2 GB RAM machine. Bhaskar is having a 5 GB RAM, 8 GB RAM machine. Devraj is having a 16 GB RAM machine. I am running my MapReduce program. Job tracker was doing the equal distribution, but why job tracker was not checking? This guy resources only 2 GB. Already he is running some job. Can I run this particular job in this? Or Devraj is having 16 GB, so I should be running 2 jobs there. Common sense, right? They never ever considered these factors. So they told, okay, the resource negotiator is to be created. Okay, let us call it as yet another resource negotiator to be created. So yet another resource negotiator came in. And then they told, okay, dividing the application, making sure that the application is running well, let us create an application master. Let us create a resource manager. Let us create a container. Revamped the complete architecture. Actually, in the original Google paper, they have written all these things. But because our guys were very, very hurried to release Hadoop, they simply did some masala work and then released it as Hadoop 1. And then later they realized that all these things has to be made. So Arun Murthy of Hortonworks is the guy who created the yarn completely. Yet another resource negotiator. And what yarn consists of? All these things. Now if somebody is asking you what is the basic difference between a yarn and the old way, a thing like this. Okay, assume that I am giving you the CD of Microsoft Excel application. You can install that Microsoft Excel, you can run that Microsoft Excel. You will be able to run only that Microsoft Excel, that's all, correct? Assume that I am giving you the Windows operating system CD. Now you tell me what you can do. You can run Excel, you can run PowerPoint, you can run whatever you want, you can create your own, correct? The first way is Hadoop 1. Only one technology was existing on Hadoop 1. That is called MapReduce. That's all. You can't do anything else like Microsoft Excel CD. It's like an operating system. So if I give you the yarn CD, you can run MapReduce. You can run in-memory MapReduce. You can run graph applications. You can run anything on the top of it. That's Hadoop 2. And in Job Tracker, there was a port 530. They deleted that port and I never ever told you 530 port is existing because it is not there. Instead, I told you 8088 is the port that is to be used. And what is the port of 8088? Yarn. And what is the version of Hadoop that we are using? Yarn, because Hadoop 2, 2.6.0. And in Hadoop 3, they modified Yarn again with architectural efficiencies, Yarn timeline server, eraser coding, etc., etc. Don't worry about that. Only the background architecture. As far as programming is concerned, not much difference except the support for Yarn, etc., Docker, etc., etc. They brought in Hadoop 3. So, Yarn is an operating system. Earlier, there was only a MapReduce application that you can do Hadoop 1.0. Nothing else in Hadoop 1.0. But when Hadoop in Hadoop 1.0, Job Tracker and Task Tracker already you know. The Job Tracker will be scheduling the Task Tracker. Task Tracker will schedule the map and reduce, right? Yesterday we have seen that. Please remember this architecture. This is how you draw. Yesterday I gave you the clear picture of how the MapReduce architecture is. Remember? That nodes and then the map and then the pipe and then the reducer. It should be. Always you should think about that. Next is this one. Job Tracker became the bottleneck. 4,000 nodes, it failed. All these things is what I have explained to you. In Hadoop 2.0, they brought in Yarn and they modified HDFS also. They call it as HDFS 2. It became like an operating system. Now you know what is Apache Spark. What is Apache Spark? Apache Spark is an application written in memory on the top of Yarn. Yarn gave you like an operating system. So if I were you and if I am running an ab initio job today, I will go there and I will take that ab initio jobs and I will Yarnize it so that there is a resource manager available and my ab initio parallelism is not limited to where ab initio is installed. I can extend it, scale it infinitely, but nobody allows it because of their job securities. But that is how you should do the digitalization. The entire ETL job can be Yarnized. And I can tell that now I have got one more called my company's ETL jobs written on the top of Yarn. And when I write it on the top of the Yarn, automatically the resource management happen. Automatically the allocation of the nodes will happen. Automatically failure handling will happen. Fault tolerance is inbuilt. And Apache Spark came in 2010. And I just told you this was around 2011 and 2012. So Spark was using a resource manager called Mesos in the initial days. And later when Yarn came, Spark supported Yarn. Today, when I write Spark, I can either use Yarn or Mesos. So that's what on is, and there is a nice animation I have created so that you will understand it very clearly. Please look at that Hadoop one reading files, and this diagram will give you all the things that you want to know. What is that below? Unfortunately, I've got a hard stop today at around 9:05. What is this all about? What is this? Data node, and each data node is having task tracker, correct? Consider all of this as Ravi, you, Bhaskar, etc. Okay. The client came in. You have the name node there. And then what is happening? The name node is dividing the data into blocks. And each data is duplicated, triplicated. Correct? And that is a picture. And the block report is being sent to the name node, as you asked. That is what the FS image is. And it happens at regular intervals, heartbeats. The client is coming in, you are typing the command. Devaraj, just now you told HDFS command is not working, you are typing the command. The command will be received by whom? The name node. And the name node is going to give back what? Where is the data? And then what happens? Look at that. It goes directly to the data node. Is the name node a bottleneck? No. And the moment you read and write, automatically that information will be backed to the FS image. So it gets updated. And on the side, what is happening? The secondary name node will have. That's it. Exactly the same. Writing files, all the same. MapReduce. How? In Hadoop 1. You have the job tracker and you have the Hadoop client. Submitted a job, let's say word count. Deploy the job into different machines. The mapper is going to give the result to the reducer. Reducer gives back the result back to the Hadoop client. Clear? Visualize it. Very nice, right? Three-hour job for that slide. Drawing all the arrows and all those things. Hadoop 2. 10,000 nodes, no problem at all. And that is per cluster, and I can have 10 clusters. So imagine. It is beyond Java. And another thing, remember when the first slide I told you HDFS 1 became HDFS 2? What is that HDFS 2 supports? Assume that there is a department in my company called retail. Retail has got a table called employee. Assume that there is another department called marketing. Marketing also has got a table called employee. In Oracle, how will you do this? Schema. Different schemas you create, right? HDFS supports different namespaces. Each namespace, inside that you will have your file system. So, namespaces means there will be many namespaces inside that. So, Hadoop 2 supports all the other things as well. And we are now going to look at how Hadoop 2 is going to read the files. Okay? Reading the files, not much difference. But there is something different on the name node that you have seen. Why? Now you have got different namespaces. And you are going to read the blocks repos as usual. And there are block pools. What is meant by block pools? Each namespace will now have their own pool, correct? And then the client is reading. It is giving back the information. and the information is going back. And please look at that very important thing. Secondary name node became active in Hadoop 2. What does that mean? If one name node is going down, no problem at all. It will automatically, what was older? Manual. That is reading files. Writing files also, not much change. This is what is making all the things change. And this is a very important slide. You have a resource manager. Yarn is coming into picture. You have an application service manager, a scheduler, and you have got queues. See how many things they brought in. Why queues? ETL job for the most important business should work with highest priority, correct? You should do the queuing of the jobs now. If a student or if an employee is running a select star, employee should be thrown out and he should be given the answer last. Whereas my business processes should be given highest priority. I need fair schedulers. I need to add all those things. Okay. So, don't worry about that. Hadoop client 1 is submitting a job. So, first let me explain you in English, plain English. Hadoop submitted the job, right? Initially it was job tracker and job tracker was doing everything. What is going to happen now? The resource manager will take, this job is going to take this much resources. And look at the nodes. Who are all running jobs? Which one are free? How much CPU? How much RAM? And I will create one application master for managing this job alone. So every job will have their own application master. Are you understanding? So I created an application master, and application master, what it is going to do? Okay, I have got the order that resource manager told me that Ravi, Bhaskar and Devraj are going to run this particular job. Let me start a container in each of these. It is equal to the task tracker. Okay, application master created 3 containers. Run the job. Application master is giving back the result back to the application service master, and then the result is given back. So let us visualize all these things.
So, Ravi, quick question.
Yeah.
So, the application master is almost doing the same thing as job tracker, right?
Not looking at all the responsibilities.
Not all, but some.
Yeah, some, of course.
Some, yeah.
They divided the task. So, but you should not say that application master replaced the job tracker.
No,
That is wrong.
So
Yeah.
all the 3 replaced.
Yes, everything together replaced with some additional features like queuing. Right? So create an app, and what this guy is going to do? Application master created, that is AM. Okay, AM is what is written here. I told you, no, an application master is created. And what application master will do? Containers. Okay, and how the containers will be created? Depending upon CPU, RAM and everything. See the difference? So look at that. Ting, 1. 3 containers. Run the job and status report is given. See? Job tracker is not the one, as application service manager is the one who is taking the status report and all. Divided the work. Correct? And then the job is run. And now another job is coming. Tell me what will happen. Another application master. So every job has got its own application master. It created the container, and I intentionally created one container here. Why? This is a 16 GB RAM computer. This is more CPU. But this one is a weak CPU. That's why only one container. This is running already a job, but no problem. And then task is created. Clear? That is what is called as yarn. And we are using yarn in our architecture. Okay. So how many of you executed that example yesterday? We are going to do that particular example. Please tell me what to do. All of you has to execute that example now. Okay. So I am coming to you. Do you need the recording for that particular thing?
Yeah, better.
Executing the job.
Yeah.
Then you have to call me. Okay. I will log off Ravi from here. disconnect, and Ravi, sign out. Yes. Okay, I signed out. And please share your screen and make sure that what you are showing there is visible here, unlike yesterday. Right. Okay, so it's a Skype. Please call me. You log in. All right. All right. Okay. So please look at this. Okay. So everyone, make sure that that screen is getting recorded. Okay. So the screen is getting recorded. You should see the screen there. Okay. What is the command that you are going to do? Give me that, please. What is the first command that you are going to do? Find out. Okay. Before that, let us create a directory called September 15 today. New one. Okay. Okay. Create a directory. Please follow me and look what I am doing. mkdir seb 15. Okay. And press enter. Right?
And I'm going to quit home Cloudera.
Sorry?
And then Cloudera home.
Yeah. In the Cloudera home. Okay. Yeah. Ravi, you can rest. You can sit there, Ravi. mkdir September 15. And now go inside CD September 15. You can sit there. Just keep his back. No problem. CD September 15. Now you are in the September 15th directory. Correct? And let us create a file in the local file system. How will you create a file? VI. And then let us call it as input.txt. You can give anything that you want. I'm just creating input.txt. Okay. And can you please create an input file? Whatever you want, you write. Let us say 2 lines with some words repeating. So I'm going to write hello, 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 world, again world, and one word you give lowercase. And one word you give H lowercase, E capital, L lowercase, O capital. Hello. I'm just making mixing and matching. Okay. And then again, I'm going to write a word. So that is my input file. Okay. Come out. How will you come out? Escape, colon, WQ. Right? So you created an input file. Where did you create that input file? In the Hadoop file system or local file system?
It should be Hadoop.
Did you type any Hadoop
Isn't
command?
this the Hadoop terminal?
It is not Hadoop terminal. Why are you calling it as Hadoop terminal? It is a Linux terminal. It is a Linux terminal.
Right, Linux.
It is not Hadoop terminal.
Oh, you mean local?
Local system.
Ah, it is a local system in the VM, but local system.
Oh, local. In the Linux.
That is very important. In the Linux. It is in the Linux. In the Mac, in the Linux. From the Linux, you have to go to the Hadoop file system.
Which is a separate system.
Which is separate system inside the Linux system.
A machine inside the
Machine inside a machine. Correct. All right. So we have to create a directory in Hadoop. Correct? How will you create a directory? Hadoop? No, why Hadoop fs minus mkdir. Let us create this directory name as sample. Okay. Please wait and please listen here. If you are in office or in your companies and all, you may write /user/temp/sample. Okay, you will give the path. But here when you write sample, automatically where it will be created?
In Hadoop home.
Hadoop home, correct?
Home.
And what is Hadoop home?
dollar Hadoop underscore home, that is the path, that is the root.
Okay. Okay. There are many things. First, I am going to create it. What it will do? It will create a directory in Hadoop. Correct? Okay. Press enter. So I created a directory called sample. Cannot create a directory. Name node is in safe mode. If anybody is getting this, then you have to type that command. Hadoop dfs admin minus safe mode leave. And then you create the directory one more time.
Oh,
Okay. Listen. If you are getting the error, then type that command.
oh, that is.
Okay, so I created that particular directory now, sample. Please understand two things. Where are you now? Are you in the Linux file system or are you in Hadoop file system?
Yeah, in Linux.
In Linux. So you are, Seiko, you have to be very careful here. This is VM. This is your Mac. What is your Mac home? Mac home. Why Hadoop? That's my computer. It will be /user/psycho something. Psycho, right? What is the home directory here?
Home Cloudera.
Very good. This is the home directory of Linux. And now what we have got inside? Hadoop file system, right? What is the home
So
here?
three processes.
Please remember, it is /user/cloudera. And understand clearly the difference. Home of your Linux, home of your Windows or Mac, home of your Hadoop. It's completely different. Okay? So, where it will be created? mkdir sample, it will be created in /user/cloudera/sample. Can you tell me how can I find it out?
PWD.
Huh?
No,
PWD will tell you what? PWD will tell you in that what?
Linux is this one.
Linux, right?
Oh,
I am asking you how to find out where is the home.
DFS7.
Hadoop
Hadoop.
fs minus ls /user/cloudera and press enter. This is by default when it is getting executed. Look at that. Yesterday I created a sample, September 14. Yesterday we created September 14 out. And today we created sample. Everything is coming. So what does that indicate? The home of Hadoop is
Cloudera.
the home of Linux is
User Cloudera.
/user/cloudera. Look at that slash. This is for your information. Later, it may, you want to search whether it is created or not, right? This is just for your information. Okay? Bhaskar, you lost. What happened?
He told me unknown command.
Array.
Hyphen ls.
User Cloudera sample.
So if we type only ls also, it will list, right? But
Now I am going to show you that. Look at this. Hadoop fs minus ls. See?
This is direct.
And now you can understand clearly. When I say ls, it is actually bringing that from that. That indicates that it is a home. Is that clear or not? Yes? Okay. So, what is the directory that you created?
Sample.
Sample. Now, it is a very good practice. Unnecessary things I am deleting. You don't have to do that. Hadoop fs minus rmr September 14 star. What September 14 star means? Any directory with the name September 14 or September 14 XYZ, it will get deleted.
What RMR is yarn?
Remove recursive Unix command.
It's
Enter,
RMR
press enter.
star. The Unix.
RMR star is everything will be deleted. You want to do that?
No,
Just now you created sample, right?
No, just-
yeah.
normally it's RM minus R, right?
Yeah, it is RM minus R. It is telling you. You can use RM minus R also.
Oh, okay.
But I want my commands to work irrespective of Cloudera. That is why I am using Hadoop FS. All right. So deleted September 14, deleted September 14 out. Look at that command. So star is a replacement. one or more replay, right? Okay. Now, I'm clearing the screen. We have got ls, the input.txt in my local file system. Now I'm going to put that inside that one. What is the command? Hadoop fs minus put input.txt to. You should not type everything by hand. Hadoop fs minus put. After that, whenever the file name is coming, I tab so that you won't make mistakes. And then give the directory name. What is the directory name that we created just now? Sample. If you want to be very, very specific, to get very good familiarity, you may write /user/cloudera/sample. But remember the diagram.
The sample is a directory.
We created just now, right?
So it's a file and then you put the directory.
Yes. First we have to create a directory and then we put the file. Alright, done. You have created the file. And what is the next command? Search for MapReduce example jar file in your /user. sudo find minus iname star.
I think user you have to give the starting.
Oh, yeah.
Yeah.
From sudo find from /user directory minus iname MapReduce. Don't make a spelling mistake. If you make a spelling mistake, you will not get any search result. MapReduce star examples star.jar. You can give.
You don't need double quotes.
So I am finding out from the last /user directory the files with have MapReduce examples appearing inside. Okay? Make sure you are taking the history of all these commands every day. How will you do that? History greater than September 15.txt, then September 15.txt will have all the histories of today's command. You use a greater than symbol, it will write to a file. And press enter. Oh, there is a spelling mistake. See, this is what I told you. RDUCE I wrote. So I won't get any files. Look at that. I'm not getting any files.
I got some files.
If you didn't make a mistake. Alright, then map, ready, I'm just changing it.
Where did these files come from?
Alright, so I have got two files now, very beautiful, I got. And I want to take the latest yarn based file which is 2.6.0, right?
Are these like files that come with
Can
it?
you please look at that what you got?
You got it.
What is the question, sorry?
Are these files that come with it?
Yeah, otherwise how is it available? It is the installation of Cloudera. When you install the Cloudera virtual
And it
machine,
comes with sample files.
everything comes sample programs. Whenever you download any software, they will give you some samples, right? Now I am going to do this. What is that? Hadoop jar.
Paste.
Throughout your life, if you want to write MapReduce program, this is the command that is going to be.
Paste.
Then take that without that missing the slash and all. Right click.
Which one?
Control C will not work. That MapReduce example. Right click. Copy.
Third one?
Copy. And right click. Paste. And what is the name of your program? Whenever you give the jar, you have to give the name of the class. Word count is the class. Remember, everything is lowercase. Why? Because that guys have written that program like that. Yesterday you wrote the program with capital. You have to remember that. Okay, so word count. And after that, what do you have to give? You have to give the input directory name, sample, because that is a file bearer, right? And then what you have to give?
Output.
Where to store the output? Let us call it as result. So result directory is going to store.
Result.
You can't maximize that. You have to go to file preferences and then increase the font.
No, it becomes small, like multiple screens.
Just to click on that.
The result folder, but you have to. It is a prerequisite that result folder you have to create first, correct?
No, automatically the program will create. That's the beauty. Input you have to create.
Yes, okay.
So, but this, like Unix, when you use the tab, that way it will not work in this Hadoop.
It will not. Why? Because it is Hadoop. How Unix will know what you stored in Hadoop? Understand? All right. Press enter, and that will kickstart your first MapReduce program.
Copy and paste. Select copy and paste.
Yes, running job.
This one. Right click. Oh, there is no right click here. Oh, yeah. You made a
It's under Command C.
No, Command C will not work in the virtual.
Yeah, no, that's what it was.
So copy
Oh, I see.
and then double click and then
Yeah.
paste, and then your input directory name is sample and the output directory name is result, and you miss the word count with the name of the program is word count. This is the command for any MapReduce program. The name of the jar file, and then the name of the class, the name of the input directory and the output directory. Output directory you don't need to create, automatically program will create, and press enter. It should kickstart your job. Okay, don't worry about all those things.
Where did word count come from?
Huh?
Word count that we created yesterday?
Word count is a new, like,
Word count is
A big
a program coming in the examples given
Oh.
by Hadoop.
Oh, okay.
So the jar file that you have written contains
Oh, okay.
word count. Jar is nothing but a zip.
Right.
So in that zip file, word count is coming, shipped
Oh, okay.
along with the program. Good question, yeah. Alright, what does that mean? It should have created the directory, right? So do a Hadoop fs minus ls and press enter. Make sure that you got your result created there.
Hadoop FS.
Minus ls. Don't ask me, it is a Unix command, it is a Hadoop command.
No, I just
You should be super perfect in that. Hadoop fs space minus ls. Look at that, result is there. And now Hadoop fs minus ls result go inside. What did you see?
two files.
And recollect what I told yesterday. Underscore success is called
trigger.
a trigger file which will be by default created. It will be a 0-byte file. Nothing will be written inside. It is an indication that the work has been started. Okay? And what is other file? Part dash r dash 1, 2, 3, 4, 5. Bhaskar, you must practice HDFS commands. I am not going to spend this much time in the next class onwards on the programs. Every time, 5 minutes, we have to complete the programs. Be picture perfect with all these commands. That is why everything is recorded. Okay. So you got that particular one. Now I want to print it back. What is the command? Hadoop fs minus cat. Okay. I told you, if you know the Unix command is cat. Just put Hadoop fs minus. That's all. What are you going to write now?
Part.
Result. No, part you cannot write. Please look at that. Look at that.
Yeah,
Result slash
result slash part.
part dash. I want you to type. Don't put star there. Star also will work.
And tab.
Because be familiar with that word.
Tab doesn't work.
R dash 1, 2, 3, 4, 5. Tab will not work because it is a Hadoop file system.
Oh, okay.
That's what.
Result dash part dash R dash 5 zeros and press enter. You should have the correct result now.
Yes.
Can you tell me why my WORLD and WORLD, HELLO and word, everything is counted as a single word? This is showing you the beauty of word count, right? All these are individual words. Unless I use case sensitive and converted everything into some uppercase. We will do that. Okay?
Oh.
If I could have done that, then I could have got hello 2 and world form. Alright. Now I want you to look at the browser.
Hello. Oh,
Open the browser. And go to remove whatever is there in the bar. Localhost. What is the YARN port? 8088. Press enter. Make sure you got success.
oh,
Finished and succeeded on the right hand side. Localhost colon 8088.
oh.
You should see the screen. Clear? And what is this ID? Anybody? Now you know everything. What is this ID? What is the meaning of that? Application master. Remember? Just now I told you in Yarn we have got, every ID has got application master. Can you please carefully copy that application master ID like this and right click and copy. Ravi, right click and copy that particular ID. Copy? Now go back to your terminal where you executed the program. See, you can see it below here. Right? Clear the screen. CLEAR, clear. I don't know whether this will work or not. Assume that the UI is not accessible to you. How will you see the logs? Type the command yarn. Wait. Let me complete it. Logs. Wait. Application ID. I capital. Control V. Oh, sorry. Right click and then paste and then press enter. Look at that. Connected to resource manager and it gave me the complete log. So that is the way of seeing your logs. Again, the command is yarn. This one. Clear the screen. This one. You have to be very careful here. I is capital. Yarn logs minus application ID. I is capital. And then give that number that you copied. Application I capital D. Application ID. Please remember this. This is how you will be seeing the logs. Whether your program is successful, whether whatever you have written is available or not, all these things are visible. Got it? And now you will be wondering, how many such examples are there shipped with Cloudera? I showed you only word count, right? Just for your information. It is for you to study. I'm not going to talk about that again. Look at that again. That MapReduce example.jar. Remember our command, right? Remember our command, right? Instead of that word count, make a spelling mistake there. Just write here word count XYZ, for example. Just make a spelling mistake. Intentionally, okay? Intentionally I know that XYZ is not there. Okay, and press enter. What is the message I got? Valid programs are. Word count XYZ is not there. Valid programs. Aggregate word count, aggregate word gate. MapReduce program use Bailey, Borwin, Pluffle to compute exact digits of pi. DB count, dist-BBP, grep, join, pentomino, pi, random exit writer, random writer, secondary sort, Sudoku. The unlimited world is open to you. Okay?
So that's extracting the jar file.
Correct.
And grabbing something.
Yes. You can refer to the Hadoop documentations, Google how to run all these things. A complete Sudoku example is there. Written
Can't you
on
do
the
like
top of
a
MapReduce.
list or some jar, like
What?
Excel or something?
Pardon?
To do the same thing instead of having to type a wrong one.
Yeah, it is there. Don't worry about that now. You are not that familiar yet. Once it is completed, I will tell you. The command is jar xvf. You can extract.
XREF?
Yeah. How will you extract a tar file? Exactly the same.
Oh, okay.
So this is only for executing these inbuilt programs.
Inbuilt, that's all. We are not interested in that. We are going to write our programs.
But jar's a Java archive.
Jar is a Java type.
Yeah.
Right. Many class files combined together is called a
Right.
jar.
Right.
Okay. That's it for today. Practice this multiple times. Okay. And make sure you're very familiar. We won't spend this time. This diagram, you want a picture? Take the picture. I will give it to the group. That how the architecture is, right? And that's all for today.